8 minutes ago, Voyager 1 just sent out a terrifying message. From space, we will continue to push the boundaries of exploration in the realms of air and space. Voyager, in a profound way, exists beyond the confines of its current environment. I recently came across some fascinating information about the Voyager spacecraft. These incredible machines have allowed humans to explore the depths of our solar system like never before. It's truly mind-blowing to think about the vastness of the universe and how our little planet is just a tiny speck in comparison. Since the advent of human technology that allows us to launch rockets and satellites into space, there has been an unquenchable thirst for knowledge about the mysteries of the universe. How do we satisfy this curiosity? The voyages have been instrumental in providing us with valuable information to analyze. However, a recent warning from the Voyagers is about to revolutionize our understanding. Join us as we delve into the discoveries made by the Voyager missions and explore the implications of their alarming message for the future. This journey of exploration has spanned nearly 45 years. The Voyager missions have played a crucial role in space exploration, offering valuable insights into our solar system. Despite not being designed for such longevity, these missions have far exceeded their initial expectations. Originally conceived as a result of a fortunate discovery by Michael Minovich, who recognized the potential for a spacecraft to ride the momentum of a planet and venture deeper into space, the Voyager mission was initially intended to last only 5 years. However, both Voyager 1 and Voyager 2 continue to journey through the cosmos. Embarking on a vital scientific mission, in the summer of 1977, 2 spacecraft were launched in close succession. Voyager 1 and Voyager 2 were specifically crafted to delve into the mysteries of Jupiter and Saturn. These remarkable vessels flawlessly conducted extensive research on these celestial bodies. In 1986, Voyager 2 made groundbreaking close observations of Uranus, followed by its historic encounter with Neptune in 1989. The flyby trips involving the 4 planets gained widespread recognition as the Voyager Grand Tour. Following this, the 2 spacecraft embarked on a new mission to venture into the farthest corners of space. In 2013, NASA made a significant announcement regarding Voyager 1. It was revealed that the spacecraft had successfully crossed the boundary that separates our solar system from interstellar space. Interstellar space, as defined by scientists, refers to the space between stars. This region begins where the sun's flow of particles and magnetic fields come to an end, as confirmed by NASA. Voyager 2 made its way into interstellar space in 2018. Currently, the spacecraft was 17.7 billion kilometers away from the Sun. The voyages remained the sole explorers of interstellar space, where they studied the interaction between the interstellar medium and the solar wind, the constant stream of charged particles emitted by the Sun. Additionally, they have provided valuable insights into the heliosphere, a crucial shield that envelops our solar system. The solar wind shapes the heliosphere, which is influenced and transformed by interstellar conditions. According to NASA, the heliopause marks the boundary between the solar system and interstellar space, where the solar wind comes to an end. The Voyager spacecraft has provided new insights into the vastness of interstellar space. One fascinating discovery is the revelation that cosmic rays are significantly more intense beyond the heliopause compared to deep within the heliosphere. Last year, scientists at NASA announced a fascinating discovery. By merging the findings from the Voyager missions with data from subsequent missions, they were able to gain a more comprehensive understanding of our Sun and its interaction with interstellar space. One particularly intriguing finding was that Voyager 1 had recorded a humming noise, which was connected to waves detected in tiny amounts of gas in the vast emptiness of interstellar space. According to Nicola Fox, the director of NASA's Heliophysics Division in Washington, D.C., the Voyager missions have provided invaluable information about the Sun and its influence throughout the solar system. Over the past 45 years, these missions have revolutionized our understanding of the Sun and its impact in ways that no other spacecraft could. Each Voyager is powered by a plutonium-based thermoelectric power system, but as the plutonium decays, the heat production decreases, resulting in a loss of power for the Voyagers. Despite this challenge, the Voyager missions have been instrumental in expanding our knowledge of the Sun and its effects. NASA reported that the team deactivated various systems, including heaters that protect the instruments from the extreme cold of space. However, the space agency confirmed that all 5 instruments have been functioning without heaters since 2019. NASA experts are still trying to understand how spacecraft can function in extremely low temperatures, surpassing their intended limits. Additionally, scientists have made intriguing observations regarding unusual phenomena occurring in the outer regions of the solar system. The heliopause, which separates the heliosphere from the interstellar medium. In the past decade, researchers have found that it is not a static boundary. This discovery was made using data from Voyager 1 and Voyager 2, the only 2 spacecraft to have left the heliosphere so far. However, recent research on the heliopause has uncovered data that challenges previous discoveries. However, the movement of the heliopause also challenges existing theories. The researchers called these disparities entry-speaking and potentially controversial in an article published October 10th in the journal Nature Astronomy. They intend to continue investigating the heliopause in the hopes of gaining more information from NASA's Interstellar Mapping and Acceleration Probe, a new and improved satellite that can detect Venus and is set to debut in 2025. According to Zierstein, we can only speculate on this odd occurrence occurring in the ghostly depths of the solar system. Till then, in the middle of May, the Voyager 1 onboard system that is responsible for keeping its high-gain antenna pointed at Earth and is known as the Attitude Articulation and Control System, or AACs, started beaming home confusing jumbles of data, rather than typical reports about the spacecraft's health and status from our vantage point. It seemed as though the spacecraft had developed a condition similar to an electronic aphasia, a condition that results in the impairment of one's ability to speak fluently. It's possible that the data were generated at random, or that they don't reflect any probable state at all, according to NASA's explanation in a statement. From the time the AACS could be in even more perplexing for the engineers was the fact that despite the strange status updates from the spacecraft Voyager, one looked to be in excellent condition. The radio signal coming from the ship is still strong and consistent, which indicates that the antenna is still aimed at Earth and is not in the configuration that the AACS claimed it wasn't to NASA. Similarly, the science systems on Voyager 1 continued to collect and transmit data as usual, despite the fact that the AACS was experiencing the same anomalies. In addition, any issues with the AACS did not activate a fault protection system meant to activate the spacecraft's safe mode. Whenever a glitch occurs, NASA engineers are quick to identify and solve the problem. In this case, they found that the AACS was sending its telemetry data through an onboard computer that had stopped working long ago. The solution was simple. The engineers commanded the AACS to use the correct computer to transmit its data. The only remaining challenge is to figure out why the AACS switched systems in the first place, as per NASA's statement. The system likely encountered an erroneous command from another onboard computer. Although it is currently deemed not a significant issue for Voyager 1's overall condition, it is crucial to identify and resolve the underlying cause to avoid any future anomalies. Over the past decade, Voyager 1 has been floating in interstellar space, far away from the influence of our Sun's magnetic field. This magnetic field has acted as a shield, protecting the spacecraft from cosmic rays and other forms of interstellar radiation. It's similar to how Earth's magnetic fields shield us from the Sun's high-energy particles and radiation. However, when a fast and energetic particle collides with a computer chip, it can cause small memory errors that accumulate over time. It's reasonable to be concerned about this happening to Voyager 1's onboard computers. But encountering mysteries like this is expected at this stage of the Voyager mission, said the expert. Susan Dodd, the project manager for Voyager 1 and 2, stated that both spacecraft have exceeded their expected mission plan by a significant margin, as they are now approximately 45 years old. We are also exploring interstellar space, which presents a challenging radiation environment that no spacecraft has ever encountered before. The journeys that these spacecraft have embarked on thus far have been truly extraordinary. Feel free to share your thoughts on Voyager 1 in the comments section below.